Alright, so make that disappear. There we go. Alright, so we've got the table, the pulleys. We labeled it as 5 kilograms and 4 kilograms. And the first question says, find the acceleration of the masses. But I really need to do something first before I start finding anything. So what's my first thing? Yeah, I gotta label all the forces. So if I go to labeling, FG's easy. There's always a force of gravity pulling down on a hanging object. What else should I label? FT. Okay. Where else is there going to be another tension force? Or actually, before I ask that, just kidding. Are there any other forces acting on this particular block? Is there anything pushing it or pulling it left and right? Just the hanging forces, like just tension, just gravity. Okay, then consider this block. What's a given? It's sitting on a table. FG and FN. Okay, so Fn, if you can see it through there, and then Jesse says it's got a tension force pulling it to the right. Very true. And I scratched out the top of the problem, we modified it, so are we considering friction? No, we're going to consider this to be frictionless, to just not complicate it further than it's already complicated. Okay, so now, next step that I would recommend is transferring it to a horizontal, as if it had been unfolded and is lying on a table. So I would start with the one that is actually sitting on a table to start with, because I'm not going to change anything. So this is going to be my 5 kilogram mass. So I've got FG down, FN up, and tension will be to the right here in the middle. I could use a different color to label the other one if that's helpful. So here's the 4 kilogram mass. Now, careful. I don't draw the G down. What do I do with it? To the right. What about tension? To the left with my red arrow. Okay, there's my drawing. Okay, the two big principles here that I think are going to trick people up are that when I'm finding the acceleration of the masses, it's for the system. I have to work it for everything, like both blocks. So when it's here, both blocks, because it even says of the masses, right? When it says find the tension in the rope, I need to work for one mass only. Does it matter which one? What did we say yesterday? No. Nope. Take your pick. I like to work it for, you know, the one that's hanging just kind of seems easier to me. I don't know. The one that's doing the moving, that's causing it to move, is what I like to work it for, but hey, whatever. Okay. So up on this one, okay, if you're thinking about it, you can see some of the work that's up there from yesterday if you want to look up to the one before, kind of cheat off of that one. Nothing wrong with it. Think about it this way too. Which way is it going to move? Think about it here on the table, laid out. It's going to move to the right. We've already said that my net force for the system has to be the winner minus the loser. So if it's moving to the right, I have a tension force to the left, and then I've got a tension force to the right, and then I've got the FG force to the right. Which one's winning? Tension basically is pulling back in some ways, because this is wanting to stay on the table, and then FG's pulling down. So who wins? No? But which force wins? What force is winning? We know, we've already established before that these two are going to cancel each other out, right? Because the normal force is what keeps the block from basically pushing through the table. It kind of counteracts that, cancels it out. So the two things that I have here at play are tension and FG. And if it moves to the right, who has to win? Gravity or tension? Gravity. Gravity's got to win. So it's going to have to be FG minus T. So back up here, if I'm going to find the acceleration up here, it's going to have to be Fg minus t. But we said something yesterday that's going to help us here. Because, what? You're going to say? Tension cancels out. Because if it's pulling with the same amount of force to the right and to the left, then technically it cancels out. So really it's just gone. Okay. So, now, net force. Here's another thing down here that'll help us as we do this. Net force is just mass times acceleration. It's the mass of the whole thing times the acceleration of the whole thing. I can break Fg down too. Fg is m times g. So you can kind of derive a new equation here of ma is equal to mg. So, go back up. I don't have much room up here. So, I'm going to refer down here. If that's okay, we'll leave it up like that. So, I've got ma is equal to mg. The difference is this is ma of the whole thing, and this is the mg of what? Just one block. Don't get confused. I can't put the same masses in both places. Because this mass right here is moving the whole system. So what I'm going to do is I'm going to have the mass of the whole thing, what's that, 5.0 plus 4.0 times A. And that's going to equal 4.0 times 9.8 meters per second squared. And I have no idea what I get. Well, that's for the right hand side. Go ahead and finish it out. What is A? 4.35 repeating. I don't have much room to put that. I'm going to squeeze it in here. How many sig figs should I give it? Does the 9.8 count? No, because it's a constant, right? It's a given. It's the gravitational acceleration. So the 9.8 doesn't count, but the 4.0 does. So 4.4 meters per second squared is the acceleration of the whole system. They're both going to accelerate that fast. If you stop and think, they should accelerate slower than gravity, right? Together? Yeah. Because is this one not holding it back? Yeah. It's keeping it from moving very fast? Okay, now, when I come down to this one, it wants me to find the tension in the rope. So when it comes down to finding the tension in the rope, I told you to work it for one mass only, and up here it was for both blocks. Looks like Christmas time with my colors there. Okay. So, okay, this time it's almost like what you could do is take yourself a post-it note or something and like cover up one of those. So if I'm going to consider this for a second with all of that blocked out, and I want to think about winner minus loser again. Is there a net force acting just on this block right here? Yep. It's a really slow answer. There has to be. Yes, because it's accelerating, right? And if it's accelerating, then my tension and my Fg aren't equal to one another. Right? So, in this case, who's the winner? Is it moving down towards Fg or up towards Ft? Fg. So that means Fg has to be my winner. So again, I have net force. I almost feel like we're starting out the same way that we did last time. I'll put Ft down here before I put T, but it's Ft or T. I feel like the confusion is, hey look, I have the same start both times, right? Except I'm working it two totally different ways. So, but this time I'm not looking at both together. I'm just simply looking at, I have this block right here that's moving. okay, I can figure out this. This should be the easy part. Start with FG. The FG on that block is going to be 4.0 kilograms times 9.8 meters per second squared. So that's just given. And I know that I'm finding FT, right? So I can go ahead and write that part in. That tells me I have to be able to find the net force acting on this block right here. So again, it's mass times acceleration. What's the mass of this block? 4.0. What is the acceleration of the block? Like the end acceleration, not the gravitational acceleration. 4.4 from before. Alright, do some calculating. $21.6 is what I get. With significant figures, what shall I give? 20. 22. $22 newtons. Okay. It doesn't matter whether the problems are 2 blocks, one hanging over a table, if it is the 2 blocks with the pulley, or if it's the 2 blocks that are on a table tied together in some way. It's still the same exact principle every single time. Label my forces, stretch it out into a straight line if it's not already, and then find things for the whole if I'm doing the acceleration of the whole system, and then find it for one block only if I'm finding it for the tension that's in the rope. Because every single one of these is going to have a tension component to it. If you've not already thought through it either, I'm going to have to do this part first, the acceleration first, in order to find the tension, because I need that acceleration in order to figure out the net force that's acting on that one block. So, you know, if I need to work with you individually on that, I will. Okie dokie, artichoke?
Oh, yeah.
Okay. So